Hello everyone. We'll be starting in next 2 minutes. Thanks for your patience. Good afternoon, everyone. I hope you're all settled and we are ready to roll. Good afternoon, everyone, and welcome to this webinar. My name is Avinash, and I really appreciate you taking your time out for this webinar. Welcome again. Some of you already know about me and pCloudy, but for many of you who are attending pCloudy webinar for the first time, let me start with a quick intro. As I said, my name is Avinash, and I am a co-founder of pCloudy.com, which is one of the fastest growing mobile app testing platform. Talking a bit more about pCloudy as product, it's one of its kind life cycle application testing platform for developers, QA, and business users. pCloudy is available in two different forms. One is the public cloud, which is one of the widely used offering from pCloudy. And the second one is for enterprises who are looking at setting up their own labs in form of a private cloud or an on-prem cloud. So pCloudy public cloud is one of the largest device cloud available today with 5,000 plus mobile device browser combinations. It's used globally by more than 50,000 users, both from QA and development community. And I'm proud to say that people from more than 84 countries use our platform, and pCloudy is helping them improve the app quality. It's one of the highest rated platforms on G2 Crowd, which is one of the third-party platforms for crowd reviews. pCloudy has been covered by Gartner and Forrester's and has been widely covered by other media platforms as one of the upcoming and growing mobile app testing platforms. So with that introduction, we are ready to start with the real agenda of today's session. And I hope some of you who joined late are also settled. So today, the agenda is around how do we optimize the device coverage and optimize the testing effort when it comes to mobile app testing. And I'm sure you must have struggled in your mobile app projects to figure out the right device metrics to use. And at the same time, you must have figured out ways to optimize the device coverage by using certain methodologies. Today, my objective is to go a little deeper and talk at more fundamental level. Why do we really find these compatibility issues? And once we understand why do we find these compatibility issues, can we use that as an information to really predict failures and optimize effort? So these are the two things which are part of the core agenda of today's session, and in that process, we'll try to arrive at certain methodology to come up with right device metrics and optimize the test coverage. So let's begin. And to set some perspective and context, I'm presenting some data points here which you might be familiar with, so please bear with me for some time. When we talk about mobile application, we talk about iOS and Android mostly. So talking about iOS fragmentation, iOS in terms of number of devices is not a big challenge. So there are overall 16 distinct iOS devices available till date. In terms of the versions, yeah, there are quite a number of versions released in the market. But one good part with iOS is most of the users update to the latest versions. So the fragmentation across the older versions are not that big a challenge. So as you can see in this chart, iOS 12 has almost 78% coverage as of now, and which is a record. And Apple by means pushes you to upgrade to the latest versions as soon as they release. However, for iOS 12 or 12.0, 12.1 itself, there are multiple devices with different form factors, older to newer devices, which still creates fragmentation issues. But when it comes to Android, fragmentation is a nightmare. And as I said, you must have experienced this in your projects as well. Again, talking certain data points here. So there are more than 24,000 distinct Android devices as of now. And this is the device we are talking about devices across the world. And the problem which gets added is because of the number of versions which are available in the market. And unlike iOS, in case of Android, the older versions are still widely used. And if you look at this chart, the latest the latest is 9.0, but the 8.0 still has only 23% of the coverage. For the 9.0 data is still not available even by Google. Hopefully it will be available in the next couple of months. But if you can look at the older versions as well, 7.0, 6.0, in fact 4.4 is still widely used, and there is a 7.6% market coverage for 4.4 itself. So you can't really ignore the older versions completely, and that adds to the complexity when it comes to the Android fragmentation. So if you try to do some math here in terms of the combinations which can exist, so there are 16 device display categories starting from 4 the screen size 4 to latest higher screen sizes, 20 different resolutions, 50 Android versions, 400 Android device manufacturers, and if you add to that the cellular networks that you need to use to test, the combinations are huge. And you can't test it on all possible combinations. So the question arises, is it really feasible to test it across such a large variety of combinations, and how can we optimize that? So there has been some traditional ways of optimizing the device coverage, and I'm going to touch upon those traditional ways briefly before we kind of move on to the approach that we use. Maybe you would have used some of these traditional approaches, or you would have kind of mixed and matched and created your own. But let me just quickly touch upon these approaches to set the context here. So there are two primary approaches which has been used widely. The first one is based on market penetration, and the second one is based on the device diversity. And let's go through each here quickly. What do we mean by market penetration? The simple way to look at is if I'm going to launch my application in a specific market, what I can look at is what are the top devices used in the market. And I can just focus on those devices because if my application works on those top devices, I'm sure of covering a maximum number of users who will be using those devices. So that this approach is typically based on the market data of usage of devices in a particular region. Um, so, for example, let's say in case of a market like India, OnePlus and Xiaomi has a huge market share, and along with Samsung. So, can you really afford just to test on Samsung, or you would like to test it on OnePlus and Xiaomi as well? And if you combine three, can you cover, let's say, 50–60% of the market share? So that's the kind of analysis you can do and come up with your device set so that you are covering a maximum market penetration here. Now, as part of pCloudy, we have a feature called Device Planner, which exactly does that. Device Planner is used by customers to analyze the market data. So as you can see in the screen here, you can select country, and if you select a country, it gives you the information about the top devices which are used in the country, and for each device then you can see what's the market penetration. So for example, in case of India, Xiaomi Redmi 3S is one of the has one of the highest market penetration with, and it is used with Android Marshmallow 6.0. So you can, if you are planning to launch your application in India market, you should definitely test it on Xiaomi Redmi 3S with 6.0. And if you look at the other devices which are there in the list, Samsung Galaxy S8, Note 8, OnePlus 5, Z4. So you can just take the top devices and test on those first before thinking about anything else. That's truly the approach based on the market data. And device planner can be used to get the data across different countries, and we have most of the popular countries available in the list, which you can use and look at the market penetration data. But there are some kind of advantages and disadvantages of the market share data. The advantages are that you choose devices with highest market share, and you can kind of minimize your effort to make sure that you are covering a maximum market percentage. However, the disadvantage is that you might lose on devices where maximum bugs can happen because you're just focusing on the top devices used in the market. And the problem with apps are one bad review can kill your rating and then reduces the download. So can you really afford not to test on devices which are more prone to error if you're just looking at the market penetration data, right? So you really need to mix and match, and that's where the next approach comes, which is the device diversity. And device diversity typically, device diversity typically is based on an approach where you want to maximize the range of devices that you want to cover as part of your testing. So the way this approach works is you can divide the device ranges into three different categories: high end, medium, and low end, and each has certain parameters. Of course, these parameters can be changed depending on your situation, but this is one of the widely used way of categorizing the devices. So high end means the devices which have higher hardware configurations like quad core, high RAM, the high display size, higher resolutions, latest OS versions. And medium end devices are falling in the medium category with slightly lesser hardware capability. And the low end are the older devices which are kind of having very low hardware capacity, low screen sizes, and older OS, etc. So you can typically categorize all the existing devices into three different categories. And then you can start looking at the top devices across each of the category, and then you fill the data that we talked about, like RAM, CPU, display, OS, and use an orthogonal approach to see how do I maximize the coverage that I'm getting across these four parameters. Because end of the day, these four parameters are the critical ones which decides the compatibility issues. So here, if you look at, let's say, if I've taken these 5 phones, I see that these 2 phones have exactly same configuration: 4 GB RAM, octa-core, 6.3-inch display, and Android 8. I'm sorry, the Android version is different, but ideally Oppo F7 has Android 8. So if all the parameters are same, you can ignore one of the device. And the same approach is followed across different categories. So here also you can see Asus Zenfone 4 and Oppo Joy has the same configuration, and then one can be excluded. So the idea is that you are removing the devices which are similar in nature and trying to maximize the key parameters, and increase the diversity of the devices. And same approach is for group C. And once you are done with this analysis across these 3 groups, you can combine your device list and come up with the final one, which can be your optimum device coverage. So it could be 10, it could be 15, 20. That depends on the amount of effort that you want to put on testing. You can always mix this with the market penetration data to see if there are some top-end devices which are not missed in this category and which has very high market penetration. So you can always mix this data with the market penetration. So these 2 are typically the most used approaches of creating optimum device coverage right now. Of course, you can add more parameters here to increase your diversity and all, but fundamentally the approach remains one of these 2. Now, we at pCloudy do it slightly differently, and as you now know that at pCloudy we support variety of versions. So anytime a new version is released for Android or iOS, it impacts our platform as well. So we ourselves have to be compatible across various versions before we can say to our customers that you can come and test your apps across the devices that we support. So we do it slightly differently. We try to predict the issues, and based on that, we try to create our device coverage and test coverage. So let's talk about that in slightly more detail here. And to do that, I think it's important to understand certain terminologies here, terminologies which I'm going to use when we talk about why certain kind of issues occur on a specific device or across operating systems. The first one is Android version, and since we are talking about fragmentation, which is more prevalent in Android, I'm taking the example of Android, but the fundamentals across Android and iOS remain same. So when we talk about Android version, there are 3 things. One is the version name, which is like Android 8.0 or 9.0. Then there is a code name associated with it. And then one of the most important data point to look at is the API level associated with that version. So one particular version can have multiple API levels. For example, one particular code name can have multiple API versions. So for example, 9.0 is 28. If 9.1 comes, it will be 29, and so on and so forth. And as I said, target API level is assigned to each Android version here. Then one other important terminology to understand is the manifest file, which is part of the app package, and it at a very high level consists of three things here. The first is the components of the app which are used inside, so all the activities, services, etc. The second is what kind of permissions the app requires. And the third, which is important for us when we talk about compatibility, is what are the hardware and software features that the app requires. So what are the lowest version for which the app should work? What are the highest version for the app which it should work? So that clearly defines the range of the operating systems or the kind of devices on which the app will work. And based on that, Google Play also decides on which devices it can be downloaded, or certain devices have to be excluded. So that information comes from the manifest file. The other key terminology to understand is the SDK versions. So there are three different terms here. The first is the compiled SDK version, which you can ask from your developer. If you're a developer, you would know, but if you're part of the testing team, you can ask your developer what is the compiled SDK version for the app. Because when the app is compiled, the developer has to mention for which SDK version this app has been built. So let's say if you choose 5.0, you have to build it with API level 21, which is the corresponding API for 5.0, which means you are using the APIs of 5.0 to build your application. So it might not it might or might not work on certain versions which are higher than 5.0, and same is true with the lower versions as well. However, Android claims that there are backward compatibilities, but we see issues there. Then the other terminology to consider is the minimum SDK version, which is mentioned in the manifest file, because you want to restrict, if you want to restrict your app to be downloaded on certain kind of operating system or certain range of operating system, you can specify the minimum SDK version. So for example, I can say I don't want my app to be supported below 4.4. So 4.4 can become my minimum SDK version. So Google Play itself will not allow the apps to be downloaded on devices having below 4.4. And then the target SDK version. This is important because this has to be decided based on the most recent version you have used, or most recent version of the Android that you have tested on. So for example, if you're confident that I have tested my application for 8.0, the target SDK version has to be 8.0. If you have tested on 9.0, you can ask your developers to mention it 9.0. Otherwise, there is a risk. Developer can mention 9.0. If you have not tested, there could be compatibility issues. And this is how it's mentioned in the manifest file. The last line is cut here, so you can see the min SDK version is mentioned 4 and the target SDK version is 15. So this will decide on which versions the app has been, on which version the app can be installed, and what is the highest version on which the app has been tested. Now, with this terminology context in place, we have reached a point where we can kind of start discussing why bugs occur in case of Android, and same kind of concept applies for iOS as well, but we're talking about the Android here for examples. So one of the reason, and we talked about it earlier also, is the fast evolving Android platforms. And as you can see here, the table kind of lists down the different versions available and their corresponding API level. So for for Oreo, there are two versions available, 8.0 and 8.1.0, and the API levels are different. And similar data point is available for other versions also. So if you can take a look at this list from 4.4, which is the last kind of popular version, which still has some market penetration, to the latest one, 9, there are more than 15 API levels which currently exist in the market. So which means if you build an application, you have to make sure that your application works across these top 15 API levels. And since these API levels are evolving and the guidelines are constantly changing, the chances of failures across the applications are very, very high. But how do we find out how a API level change impacts our application is what we'll go through in a bit. But one of the key reasons why we see bug compatibility issues or app compatibility issues is the change in the API level from Android ecosystem itself. The second reason is, and again, we talked about at the beginning, existence of more than 24,000 devices in the market, more than 400 OEMs available in the market, is the, and I'm calling it myriad device models here. Now, what happens here is to meet the market demand, the manufacturers like Samsung or Xiaomi or OnePlus, they keep releasing new Android device models with diverse hardware. So a phone will have a different screen size, camera quality, sensor compositions, etc. And on top of that, they also customize their Android operating systems by modifying the original Android software stack, right? And that causes a maximum number of compatibility issues. And to understand that, the table kind of lists down the typical Android apps stack which is used by OEMs and the changes that they do. So they do two kind of changes here. The first is the lower level system, the bottom two layer that you see, which are hardware abstraction layer and the Linux kernel. Now they change these two layers to create specific drivers for a particular device, and they create new drivers so that there is abstraction available to the higher level system. So for example, if there is a new kind of voice recognition system available in a particular kind of device model, they will create those specific drivers at the hardware abstraction layer, which will be used by the APIs in the higher level system. So that's where a device specific driver or device specific hardware creation happens. Now, if those drivers are not properly created, and if these drivers itself have certain bugs, the APIs consuming those drivers also will have the bugs. So that's where we see a lot of compatibility issues. Now, apart from modifying the lower level system, which is the hardware abstraction layer for specific devices, these OEMs also customize the higher level system. So for example, you see the UI design of different OEMs different from each other. So Samsung has a different UI design, Xiaomi has a different UI design. So they basically customize the higher level systems, which are the top three layers mentioned here, to create differentiations for themselves and the devices that they are planning to sell. And these changes also create compatibility issues. Now, to understand more about it, let's look at certain examples. And we have done analysis across different bugs that we have seen over a period of time. And we have looked at data available on internet as well. And this is the kind of summary of compatibility issues that you will find out. So the left, just focus on the left side of the table first. There are two kind of compatibility issues which exist. The first category is the device specific issues, which means that these bugs are related to a specific model of a device or specific category of a device. So for example, certain kind of bugs will only happen on a Samsung device or a specific model of a Samsung device, for example, Samsung Note 8 or Amazon Fire. So that falls in the category of device specific issues. But then there are a large set of issues which are non-device specific, which means these issues are related to, these can happen on any device having a specific operating system. So these are these happen because of the API levels that we were talking about. So now if you look at the root cause, in the device specific, there are three main root causes. The first is problematic driver implementation. So we talked about the driver creation at device level, and if the driver creation has certain issues, it will create bugs within the applications as well. So just to look at one example of a problematic driver implementation, there was a very famous proximity sensor issue in Samsung devices, which means that if you bring your phone near your ear to talk, ideally the touch screen should get disabled. But in certain Samsung devices, it was happening otherwise. If you bring it near your ear, it used to get enabled, and if you take it far, it used to get disabled. It was because of a problematic driver implementation. It was returning a reverse value. So that falls in the category of a problematic driver implementation. And there are, if you look at the percentage of such issues found, 23% issues are because of problematic driver implementation, which are very device-specific issue. The second category, second root cause within device-specific is the OS customization, which kind of covers 10% of the issue. So, for example, Samsung came up with a new feature for their phones called multi-window support, which is not available in a lot of other models, which means in a single screen you can open multiple applications and you can work with multiple applications together. Now that feature created a lot of bugs within applications. So that's a classic example of OS customizations creating certain app-specific issue. And then the third one is a peculiar hardware composition. So in case of Amazon Fire, there was an issue with the video player itself because, again, it has a driver issue with OMX codec. So I mean, I'm not going into that detail, but in terms of the high-level understanding, device-specific issues are in three different categories: the problematic driver implementation, OS customization, and peculiar hardware composition. So this is where the focus on testing on variety of devices is important, but this only covers almost 40% of the compatibility issues. The large part of the compatibility issues, almost 60%, falls in the category of non-device specific issues, which are because of the changes in the Android platform APIs or bugs in the core Android system itself. So if you look at the category here, 47% of the issues are because of change in the API level. So each time a new version of the Android is released and the API level is changed, it creates certain backward compatibility issues or it creates certain issues with respect to the new version which was released. And large percentage of it falls under this category. So for example, in case of Android 8.0, which is API level 26, they changed the way the internationalization on the device works. The API which takes care of the internationalization was changed, and if your app works across different languages, there was a failure, right? And that was a widely kind of known issue with 8.0. A lot of applications started failing. So similarly, there are multiple such issues which can happen when an API level, a new API level is released. And then the last category, which is the original Android system bugs. Again, this is a significant category where the Android core itself has certain issues. Now, these issues get resolved quickly because as soon as these are reported, Google releases a patch and these get fixed. But for certain duration, your applications might see these kind of bugs. For example, with 8.1, a widely known issue was reported with Bluetooth. So if your application was using Bluetooth for data transfer, it would fail on 8.1. So this was because there was a Bluetooth issue in the original Android itself. So if you look at the overall table here, I mean, again, summarizing, almost 40% of issues are device specific. However, 60% issues are non-device specific. which are related to API level combination. So now if you have to kind of decide your device metrics, you have to take both the aspects in consideration. One is how do you cover the device specific issues and how do you cover the non-device specific issue. In case of device specific, things like device diversity matters, but in case of non-device specific, you have to focus more on different kind of versions, and again based on the changes which you are going to test. And that takes us to the next stage as to how do we predict. And if you, I'm not sure whether you follow the release documents which are kind of shared by Google, and it's available in the forums. The release note clearly talks about the changes which can happen on all apps, or changes which or impact which will happen on the apps created for that specific version. So for example, this is one snapshot for Android 8.0, where there are two categories. The first one is changes for all apps, and then it lists down what are the kind of changes. Of course, it's slightly technical in nature, where it's more developer oriented, but that is where we'll come to your help. And the second category is if you are developing a new app targeted for 8.0, then what are the changes that you'll have to plan. Now that's the, and this is the Bible, where if you go through this, you'll be able to predict what should be my test cases, what should be my devices for which I need to plan my testing, what are the functionalities that I should focus on, where there are maximum chances of failure, rather than just blindly testing all my application, and I might miss the key areas where these changes can impact. So this is the Bible, and if you're following the beta releases and all, you'll be able to plan your testing well in advance. But what we have done with pCloudy is we have, I mean, our developers can understand this, but we thought of creating something which is very friendly to the testing community, and we wanted to create some kind of handbook which the testing community can use, and then start using that handbook to plan their testing and plan prediction of failures in their applications. So we have created the handbook for 8.0, and we are kind of in process of creating handbook for other versions as well, which will be available soon. And I hope you would have got the upload here, which you can probably download, which you'll be able to download. What you see here is a snapshot, but if you see the document, it covers the full list of changes and the kind of test case that you should focus on if you are planning to test your application on 8.0. And just to kind of summarize it here, or give you a sense of what this document talks about, so this screenshot covers two test cases. So if you look at the app column, it says if your app has a functionality, then you should focus on this test case. So for example, the first test case says if your application uses current location of the user, then 8.0 change has an impact for you, because Android has restricted the number of location updates when app uses the background service. And that's one of the reasons why you would have seen recently that in case of Ola and Uber, the location updates are not very accurate compared to what it used to be earlier, because Android has restricted the number of updates that they can get within a certain duration. So they have to change their implementation if they have to get the latest updates that frequently. And if your application also has a similar functionality, you will have an impact on that functionality in terms of the user experience, or you might get some errors as well. So we have mentioned the test case as well, and this is a generic test case because we're not talking about one specific app. It's just a guideline for you to understand how can I use this test case in my application functionality. But the first row talks about if your application has a location feature, you need to test on 8.0 thoroughly because there is a change in 8.0 which will impact. The second one is a similar change, background execution limit, again to improve the performance and the battery life. Android has restricted the number of background executions that you can do for your services. So here you'll have to talk to your development team to understand where your app are, which of your app functionalities are using the background services. And if you know those functionalities, you can start testing those functionalities specifically rather than testing everything at one go. And we have seen so many failures with this change. There are exceptions coming in. In fact, we also faced this as soon as this change came, and we had to correct this. So if your application is using certain background services, and if they're using an older API, and if your application has to be supported on 8.0, it will fail, and if you don't want the failure, the change has to be done by the developers. So similarly, if you look at the document, it has all the changes mentioned. I'll just open the document for you to kind of give you a full overview, but I hope you have got it for download, and feel free to share your feedback and thoughts here. If you have anything else to be added, feel free to let us know. So you can see here, I mean, there are almost 10 different impact areas that we have covered, and each impact area has multiple test cases which you need to consider. So this is one way to start predicting or start planning your test cases to be executed, and also on the kind of devices that you should plan for testing, rather than just blindly testing it on the approach that we had discussed earlier, which I'm calling it the traditional approach. This is the approach that we are kind of using it to predict the failures beforehand, rather than wait for the failure to happen and then take corrective action. So we'll be releasing this kind of document for all versions. So we are releasing it for 8.1 and then 9.0 within a couple of days, and you'll be able to get an update on these changes. And the easiest way to get those updates is if you are following our LinkedIn page. We are releasing all these updates on as and when it's available. So best way to get it is to start following the page. So coming back to the end of session here, or the approach that we are following is let's not test, let's predict. And there are scientific ways to predict. We talked about certain data points. If you want to know more information about those data points, we'll be more than happy to talk about it. But if you look at that scientific approach, you'll be able to optimize your test cases as well as the kind of devices that you should plan for your testing. So with this thought, I'll end this session. Thank you so much for joining, and hope you are able to take out something from this session. We can now open it for question and answer. Feel free to drop in your question in the chat window. We'll be happy to take few of the questions, and if there are more questions, we'll answer it individually over emails. Thank you so much. It was a pleasure talking to all of you. So there is a question here. What is the basis of device planner? I mean, from where do you get the info from the market penetration? So yeah, that's there is a way to get the data. There are analytics portals that we use to gather that data, and there are analysts who are constantly analyzing that data to make sure that this data is correct. So there's a well-defined process behind the scene which goes to gather this data, and we have been using it for almost 2 years now, and most of our customers have benefited from it. So there is a scientific way. I can't kind of get into detail of from where do we get this data. There is another question. Regarding UFT integration with pCloudy, when can we expect that? Okay, so this is slightly different from the topic that we were discussing. Probably I'll come back to you directly over email. There is a way to use UFT with pCloudy using the device tunnel. We'll give you more information on that over a separate email. There is another question. All the three groups will have same 4 parameters. I'm not sure. I couldn't understand the question. Maybe we'll connect with you to get more detail about that question. There is another question from Deepak Kumar. How can we get to know that which version of Androids are mostly used? So that data is publicly available. The best source is Google developer portal itself, which updates the market percentage of a particular operating system version on a regular basis. So the data that you saw in our PPT was data till October 2018. Very soon, probably by next month or so, the data should get updated with the addition of latest 9.0 version as well. So the source is Google here. The best source is Google. There's a question from Pankaj. Android release cycle is shared periodically, so how does that factor in our testing of the app on latest versions? If I understand the question correctly, for any new versions that comes in the market, how do you plan your testing? If that's the question, as I said, for each version there is a beta release also available before the release, the main release happens. So you can always track the beta release to know what are the changes that are coming in the main version of the release. And based on those changes, if you can analyze, and we'll be sharing this cheat code for those beta versions as well. So that will help you kind of plan what are the kind of changes which are coming in the version, and you can customize your test cases accordingly, and you can plan your devices accordingly. There is another question from Shyam. Can you kindly tell me where you get the iOS and its fragmentation chart? Is it available on Apple portal? So unfortunately, Apple does not release this kind of data publicly in the market, but there are other portals using which you can get this data. And as I said, we have analysts in place who are looking at this data on a continuous basis. So you can always look at the device planner that we are providing and kind of use that data to plan testing on Apple devices per se. But as I said earlier, the advantage with Apple is majority of the users upgrade to the latest versions. So your target should always be to test on all devices on the latest version, and then probably one version less for sure. So if you're following the latest and latest -1, you'll be able to cover maximum fragmentation for iOS specifically. So you talk about 3 groups of Android devices. So are we considering same parameters for all groups, RAM, etc.? Yes. So if you are taking the device diversity approach, yeah, these are the 4 key parameters: RAM, CPU, display, and operating system to be considered. And across each category, you can maximize the diversity across these 4 parameters. So you can use the orthogonal approach to see that you're not taking the same parameters across different devices. So yeah, these are the 4 main parameters that you can use. Another question from Gopinath: is pCloudy platform similar to testing solution from Experitest Appium Studio? So fundamentally, yes. Both are mobile testing platforms, and we also, pCloudy is an end-to-end platform, so you can use it for both your app testing on a variety of devices. You can use it for creating your automation scripts, and you can use it to run your existing automation scripts like Appium, Espresso, etc. We also have another integration with crowd testing. So if you want real user feedbacks, again, you can use pCloudy. And one of the key differentiator that we have is our autonomous testing. So you can use our bot to test your application completely on its own. So you just upload the application and bot will do the end-to-end testing for you. And it generates insightful data for you to analyze. So that's one of the major differentiators between pCloudy and other platforms. How does one question from Pankaj G: how does the functional and non-functional testing impacted by the release of new versions Android and iOS and the corresponding API level upgrades? A very interesting question. I think that's a good, in fact, feedback also. We didn't include that in our handbook. Yes, it impacts the performance as well. For example, in case of Android 8.0 itself, there has been many changes done at the HTTPS and network level, which can impact the application performance. For example, we have seen because of the network change, if you switch on your Wi-Fi, the application takes time to again connect back to the network. And let's say if you have some timeouts in your client server communication, it can impact the application behavior. So there are quite a number of performance issues as well, which can happen because of the API changes. But that's a good point. We'll include that specifically in the handbook. Another question from Nandis: how to predict non-device specific issues? So I think the handbook is designed to predict non-device specific issues. So if you follow that, it kind of takes care of all the changes which are part of every API level change or every new version release, and it has listed all the impact areas. So now you have to map it with your application if those impact areas are relevant for you, and if those are relevant for you, you should consider those test cases first before testing anything else. There are some more questions coming in. But for the time consideration, we'll come back on those questions individually. We'll share the responses over email. I'll respond to you over your email ID. Thank you so much. Thanks for sharing your questions and your feedbacks. And go through the handbook. And if you come across any other things to be included, if you have any suggestion, if you find out something is missed, point out. We want the community to participate in this exercise. We want the testing community to use it as effectively as they can, so that we can help everyone minimize their testing effort with respect to their mobile apps. Thank you so much. Thanks for being part of this webinar. And do follow our LinkedIn page to get the latest updates. We'll be releasing more of these handbooks very soon. Thank you so much.